Hello, good morning and welcome. So I've met almost all of you already. So I'm starting with something very general. So today I'll give you just the basics of quality of experience, some work we did, preliminary work, and then Marco tomorrow will give you some more insights. So I wanted to start, this is interesting. What's your name? Yeah. Juan. So that's more interesting for you maybe, but also for you guys. You are PhD students, right? PhD, and you are? Master students, and then faculty, so you can come and visit us. I know, Marco, but Rome, you don't need to talk too much about Rome. While Padua, I'm originally from Rome, then I was there a couple of years ago. If you go to Lisbon, they will tell you this is our saint. We had a discussion last week, but okay. Usually, you know, when I tell people I'm from Padua, where is it? Well, it's in the north. It's already cold there, and it's close to Venice. Very, very close. So Venice, I'm sure you know it. It's 20 minutes by train. So my weekends when I'm there, I visit the city. The university is extremely old. The numbers usually, I don't remember them, but we have, let's say, population is 200,000 people in Padua. And 60,000, now they're saying 70,000, they are students. So it's a university inside a city that is a university, everything is mixed up. It's very, very nice. So it's a very old university, as I said. It's the second most ancient in Italy after Bologna. And this year we're celebrating 800 years. So we have a lot of interesting things going on. We have 32 departments. 26 of them applied for being, in Italy we have this excellence department, so very high level of quality for research, academics and so on. So we are kind of proud of this university. And this is one thing that when I first entered the rectorate, it was for me impressive. So this is the place where Galileo used to teach the students, so I can tell, you enter there and you feel the power of the research that has been carried out since 800 years. So as I said, we're good, we are proud. So I'm not the one who prepared those slides. This is definitely one person from Padua, but we are very proud of this. So we ranked first in the most recent evaluation of excellence in Italy. So I think it's a good, very good university. So if you want to spend some time also for exchanging 1 week, 2 weeks, if you want to deliver seminars, whatever, you just contact me and I can tell you how to do it. The university is very nice and small, and the Department of Information Engineering, from which I'm from, and where you, Juan, will go if you get the double degree there, it's in the south part of the city. It's close to the river, so there are a lot of small rivers going around the city, like Venice. Okay, it's not like Venice, but still. It's a nice place. This is the building, let me see. This is not where I'm staying, but it's not very beautiful, but still the environment is quite nice. Roma 3 gives me these things that are not working. You're talking about too much about Padua, so this is complaining. So as the name itself says, this is the main department in ICT studies. We have bachelor programs, master programs, and our master is completely taught in English. And it's the next slide. I'm not spending too much, what? See, I'm not spending too much time on this because we will have a dedicated presentation later on in the afternoon. So if you want to join it, I don't know where Narciso and Jesus, you know where it is. Okay. I'm teaching in this master that is ICT for Internet and Multimedia, so the name tells you more or less what are the topics that are covered. It's very nice because you can pick from a very big offer, and we have 4 curricula. And inside this curricula we have different tracks, but okay, let's say that we have Telecommunication, Cyber Systems, Photonics and Quantum, ICT for Life and Health, that is like applications for bioengineering. Bioengineering is a different thing that we have. And okay, if you want to know more about the courses that we have or all the opportunities that we can offer, you can check the website. Then I'll share the presentation so that you have all the references, QR code, link, and so on. So I'm there. I'm in Padua since 2 years, so I'm pretty new there. but I already feel it like, yes, now it's working, like it's my university. And as Jesus was saying in his presentation, I'm mostly working on quality of experience for multimedia content and subjective and objective quality assessment. If you're not familiar with that, you will be after today and tomorrow, I'm pretty sure. I know the two of you are the experts in this case. Okay, and you? You also, okay, 1, 2, 3. So maybe I'll tell things that you already know. But so what I wanted to talk today is just to give an introduction on what immersive media is, quality of experience, what it is, how we measure it, what are the new challenges nowadays that we're going towards immersive media. So let's say that the key word for this talk and tomorrow's talk would be immersive. Yeah. So immersive media, when we're talking about this big word, we are basically referring to these three things that are virtual reality, augmented, and mixed reality. On the two, let's say, extremes, you find virtual reality. So you usually have a headset, you wear it, and then you are completely immersed in a virtual world, and you are detached from the real one. And it's a bit tricky sometimes. You cannot really walk and feel free to move in space unless you have something like that. I don't know if you know it. This is a treadmill. And you have your head-mounted display. You wear it, so you get immersed in this virtual reality, and you start walking. And the treadmill will push you back in the center of the space, so you have unlimited possibilities to walk. I've tried. I fell. So yeah, it's nice, but not that is so friendly to use. On the opposite side, we have mixed reality. So mixed reality, as the name itself says, is mixing virtual object, graphical, computer generated usually, and then we have reality. Those things are mixed together, and let's say that technology here is a bit less mature than VR, and this is why I will concentrate my talk later on VR. The difference among these three classes that we usually refer to immersive media is in the interaction way. So there are different levels in which we can interact with the content. In virtual reality, usually it's a bit less. With augmented and mixed is a bit more. And also the points of view that you can change while moving. We will see it in the next slide. You can do it in several ways. I don't know, have you ever used these mobile phone applications for VR, like Google? No? Yes. So basically, you can open this Google that gives you direction based on some landmarks that you can find in space. Or you can go to more sophisticated and expensive devices like head-mounted displays. Have you ever tried head-mounted displays for VR? Yes, yeah, but okay, but PhD students, I guess. What about the others? Yes? Students usually.
I tried when I was pregnant.
Okay, good. So everybody tried. Yes, that's like the idea. Okay, so good. You know what I'm talking about. This is not obvious. Very often when I ask my students, they have never tried. So that's good that you know. So you know what I'm talking about here. We are expecting a big increase. So there is this forecast, and you say, virtual reality has been there for many years. So with Narciso earlier we talked about SPIE, this big conference in San Francisco, and I remember in maybe 2010 we already had some virtual reality devices that were used mainly for gaming. But now we have a lot of computational power, good devices that are increasing the quality, which I'll talk in a moment. And so you see that there's an increase in the request of devices for VR. This is the red graph here, while the orange one is augmented reality. What we see here is we are moving towards a larger and larger use of these technologies, and especially the gap between VR and AR is kind of reducing because VR is kind of moving forward concerning technology. This is not the first time we try to go into something that is more immersive. So the oldest year, for sure, but I think also the youngest, we remember the release of Avatar in 2009. It was like, whoa, 3D is coming. We are going to use 3D everywhere. So we had 3D computers, 3D screens at home. I remember going at the supermarket and finding these big monitors. You had those glasses, active and passive, heavy. Okay, they were not so comfortable. And this is the reason why, one of the reasons why 3D failed. But this is not the first attempt. We didn't learn from the past because 3D dates back. I mean, it's born in the end of the 18th century, mid 18th century, it's not the end. And then they tried again in the 50s, then they tried again in the 70s, and then there are some other attempts, IBM and NASA also in the 90s. And I like the attempt for virtual reality in 1968. So you have this computer-generated cube that is going around. Okay, now it's over, but they didn't work. So still nowadays we are struggling to understand how to use effectively these devices also for different types of applications. Why? What happened? For sure, one and easy answer to this question is that technology was not ready. So if you go back to this sword of Damocles, you had these bulky systems that were heavy and difficult to carry. And also nowadays, augmented reality, it's not so heavy, light. But there were some other things that were not considered. First of all, the discomfort. I don't know if you ever tried a 3D screen, 3D television at home. So you are sitting comfortably on your couch and then you have to wear the glasses. And then you have someone that is sitting close to you that doesn't have to go too far away or too close to the screen, otherwise the 3D feeling is lost. So you have a lot of constraints. Even if you go to the movie theaters, it depends on when you're sitting in the movie theater, because if you get to specific spots, the 3D effect is kind of annoying. There are also some health issues, and this is something again that I've checked with students, and personally I don't have any kind of problem, but there is this person here in the first row that will throw up any moment for 3D. So you can have, feeling like nausea, eye strain, you can feel dizzy. There's plenty of problems that may occur physically, so you don't really feel like, yeah, I'm going to watch a 3D movie. Poor visual quality, but this is of course changing nowadays, even if the color reduction is given when you have 3D, because you need to wear some glasses and this somehow will affect the quality of what you are looking at. And finally, there is not a real demand. We are fine with 2D, that's the point. We like 2D. It's fine for movies, videos, and we are sharing nowadays also on the social, plenty of videos. We know how to use it, we're good with that. It's easier to share, and we're sure that everybody will look at that. So there was not a real demand for 3D. So what we know now is that there are technical issues, but they're not only technical. So there is one step further that has to be done, that is to consider the person that is using it. And here is where we can introduce this new, it's not me, I was not almost there at that point, but where the topic, the idea of quality of experience appeared. Before 2013, when it was formalized, the most common way of assessing the quality of a system or a transmission was what is called quality of service. I think everybody studied here, if we are in the telco environment, network or whatever, when we studied the quality of service that can be measured through different elements. So delay, latency, jitter, and all these kind of features. And actually, ITU, one of his recommendations, say that the quality of service is the totality of characteristics of a telecommunication service that bear on its ability to satisfy stated and implied needs of the user of the service. So the focus here is on the telecommunication service, if it's good or if it's not. And then consequently, we will get different levels of quality of service. Well, moving from, let's say, a telecommunication-centric approach, there was the need of putting the human in the loop. And when it comes to quality, then things get a bit tricky, because if I ask you to tell me if something is good or not, we will mostly agree. But then if we have to define what quality is, it's extremely difficult. So you can go to vocabularies or whatever. I thought I had a slide, but I don't have. I don't know if you're familiar with this elephant story. So there is a story that Indians tell, and then there are a bunch of people that are, they have something on their eye, so they cannot they cannot see what they're touching, and they start touching a big elephant. So they're touching the same thing, but different parts of it. So depending on the part they're touching, they would say that it's a different thing. So the experience is unique and depends on the person. And here is where quality of experience becomes kind of difficult to assess. We're looking for a definition of quality of experience. We end up with this. And if you read this sentence, definition of quality of experience is, it results from the fulfillment of his or her expectations, so this is the user, with respect to the utility and or enjoyment of the application or service in the light of the user's personality and current state. It seems easy. There's a bunch of stuff that is difficult to model. So you have the enjoyment, you have the expectations, you have the personality, and you have the current state of the user. So it's not so trivial. But this is a big moment in which the telecommunication world also had to admit that quality of service was not enough. And this is witnessed by the fact that there's a lot of standard and groups that are working to define this quality of experience. Probably you're familiar with some of them, PhD students for sure. So VQX, this is where we met with Jesus, then JPEG is working, IEEE with a lot of standards. So there's a lot of work here that is still ongoing, trying to figure out what is quality of experience, because as we will see in a moment, when it goes to immersive media, the things get even worse than for classical 2D and to some extent 3D content. So when talking about quality of experience, there are many questions that we can ask ourselves. So what are the factors that can be used to assess the quality? So if I want to check if you enjoyed my presentation, what are the things that I should ask? If you understood my English, if my tone was correct, if the slides were okay, I don't know, it depends. So the factors that you select will also affect the way you evaluate the quality of experience. And then there's a big difference, we will see it in the two or three slides, between our experience in 2D and 3D. So 2D, somehow it's something we're used to, so we know now how to evaluate the quality of something that is 2D. And once you understand all this stuff, can we define some guidelines? So if you want to run subjective testings, can we define some guidelines? And also with Jesus, also we did some work towards this scope. This is only few items, and there's plenty of them, but they depend especially on the specific devices that we're using. For example, for rendering, what are you using? Hand-mounted display, a mobile VR, augmented reality, virtual reality. So the rendering devices affect the type of experience that we have. And plus, you have the expectation of the user and many other things that come into place. So, one first trial was to try to identify what are key features, as I said. And as everything new, we start from what we know. So, for sure, there are some quality features that are relevant for the 2D case that are needed also for virtual and augmented reality, so immersive media in general. And the first was the audiovisual quality. So if we're looking at something in immersive way, we want that it has a good audio, a good resolution, and especially that they are synchronized. Otherwise, we might have some discomfort there. And then other issues that need to be taken care of, the compression and the transmission. Again, we're moving to contents that are heavy. There's a lot of data to be transmitted to grant a specific level of quality. So we can look into that and the trade-off that is needed between the transmission and the compression rates. We know this. We know how to model this stuff from the 2D case. And then there are other things that are specific of the immersive media. So the presence and interactivity. I've tried several things in virtual reality, for example. So sometimes, like, you walk, you don't see your feet, this is annoying, and you don't feel you're really there, or like you're moving. Then, you know, for an Italian that moves quite a lot is her hands. If I don't see my hands, this can look a bit weird. So there are some ways in which you might want the user to feel in the scene. So usually, yeah, you will try virtual reality, you have the controllers, and you have those controllers and you can see them in the virtual world. Capture system, as I said, is definitely affecting what we are going to look. So this is another quality feature that we can consider. And the display system, and also the sickness. This is another point, how to evaluate the sickness that people feel when using this immersive media. Usually this is done through questionnaires asking how you feel before, during, and after the experience. So we started working on these topics a few years ago, and we focused on virtual reality because, as I say, the technology is more ready with respect to augmented and virtual reality. And something that we targeted, and actually this was given because of a grand challenge that Jesus also participated in organizing, was trying to model the visual attention. So if we have a good model of visual attention, at least I can start, let's say, trying to set up some of these features. So if I know that I'm in a virtual world and I will pay attention to some specific aspects, then maybe this can help me in designing good models. Oops. So the first thing was to define what is called saliency. Are you familiar with this? No. See. This is he has a poker face, so I don't know. I'm looking at him because it looks, yeah, saliency. So saliency points in an image or in a scene are the points that attract our attention. So I will be focusing my attention on your faces because you are in a good position. Maybe Esther's face is even better because for me, I don't have to tilt my head. She's perfectly there. So there are some things that we know that attract the people's attention, and this comes from psychological studies from the 70s. So we know that there are some things that attract our attention. Many engineers in the past have developed pretty good algorithms that can predict where the attention of a user will focus. So this is an example of a 360 image. If you have never seen this, you did, I'm sure. This is like the panoramic picture you can take with your mobile phone, or you can use specific cameras. It's a 360. I mean, you can see it in this format because that's the only way I can show it in 2D. But if you put it in a head-mounted display, this will wrap up and you will be in the center of the scene and you can navigate the content. What we can see, some important things here. Okay, I have the pointer, it's easier. You will see that the attention, so where it's red, it means that the people are looking more into those spots, and blue less. So again, it's not working. So you'll see this pot of flowers is kind of attracting mainly the attention, and people are looking in the center of the image. They're not looking a lot around, and in a couple of slides I'll show you why. So one option, one thing that has been noticed through extensive subjective tests that have been implemented is that when people look at 360 picture, they're basically paying their attention not necessarily in the center, but slightly above and under this bias that is in the equator line. And so this is the first finding that we try to incorporate in our studies. But then there is another thing that I found extremely interesting, is that we are lazy beings. So basically, it's true, we are given the possibility to have virtual reality, to look around, but we are lazy. So we don't want to move that much our head. And especially if you're wearing head-mounted display, they're heavy. some extent. Not extremely heavy, but if you use it for a longer time, then this can cause some strain. And so basically we move our eyes, a bit our head, but up and down is tiring, and then we are hardly moving the entire body. So you never look on the bottom or on the ceiling. This happens very rarely. So a work that we did recently was trying to combine all those information, and starting from the knowledge that we have for 2D, trying to understand if we could find a model, a saliency model for 360 images rather than 2D, and see if there were differences. So we gave for granted the fact that there are some things that are relevant even in virtual world. So what we called low-level and high-level features. The low-level features are the classical ones: saturation, the presence of edges. Like you have an example here with these flowers, this white daisy, I think. They are really catching our attention because they are completely different in saturation and color from the background. On the other hand, we have what are called usually the high-level features, so things that are more related to the semantic content of the scene. Like in that case, you have these hot air balloons that are definitely attracting our attention. So there are specific objects and especially faces. We really like looking at people and faces in the scenes that we are looking at. So for low-level features, we based our studies on psychological works that have been carried out before. So we selected bright and highly saturated regions, so something that really is different. Like here everything is bright, so that I wouldn't use that feature, but still. The presence of texture and edges. So I'm really visible for you. Okay, I'm talking, this is already one important cue, but you know, the background is white, is flat. I'm kind of colored, I have a face. So I'm definitely attracting your attention. So we use also in this case the state-of-the-art techniques that are pretty easy to extract what we define low-level feature. So you have a 360 image, for example, this one. And then you extract the low-level feature. So textures are there, edges are there, almost everything is relevant. So low-level features are interesting, but they cannot be used exclusively to define the saliency of an image. So we paired this with information that we retrieved for the high-level features. So faces, we are looking for faces and larger objects. Plus, usually, if we have something that is repeated multiple times, we lose our interest. So this is less salient in our exploration. So again, we use state-of-the-art detector, the YOLO detector. I think you know it. It's a very effective object detection system that can detect also small objects and large objects with very good accuracy. And then the result that we got only using the high-level feature was this one. So basically only the faces of the person were recognized. We lose completely sight of the low-level features. So we said, okay, we extracted the low-level feature somehow, we extracted the high-level feature somehow, let's see how we can put them together. Okay, now it's good. Okay, so we start from 360 image and there's a viewport extraction. This is just a pre-processing step that we need to process these 360 images. We extract the low-level and high-level features exactly as I've shown, and then we use the information that we know about the fact that we are looking at the equator. So we have, let's say, we weight the map that we get by considering this bias of the viewing behavior. And then we weighted this again with the physiological features. So we consider that the parts that are within our eyesight are most likely to be visited, and then we reduce the weight for the other parts that need a complete movement of the body. And this allows to get the final saliency map. Yes. That's what we came up with, the saliency map, and how to assess if we did good or not. Well, we have to compare with the ground truth. So recordings of people that really looked into these images, their head, their site was tracked, and this was used to get the ground truth. And this is what we obtained. You would say 85%. It's kind of small, yes, but we're really proud of that because this is the best we could achieve so far. And actually, it was an improvement in respect to the existing method. I have to say that after 2017, when the grand challenge, in which this was a task to define saliency models for 360, there was a bunch of techniques that were developed, and then at some point they stopped. So it's very difficult now. We couldn't find recent works dealing with this. So you see, our comparison is still 2019. And to be honest, I think that this one is also one of our previous work. So 0.65, 0.85, we're very satisfied with that. But still, this is something that needs to be investigated. But I know, it doesn't like Real Madrid, doesn't like me. So I said 360 content, they are good for virtual reality, but this is only a part of the story, because if you go to, to look things in a more detailed way, you can actually have the idea of having different contents, and those are given by point clouds. Again, I think you know what point cloud is. And things change again. So from 2D, we moved to 3D, and then we went to virtual reality, and now we have point clouds. Again, there's a lot of, we have to restart considering what is saliency, for example, again. So there are several challenges when we're dealing with point clouds, and this depends from different aspects. So the acquisition artifacts, there can be different devices using to record point clouds with very different resolution levels, and depending on the resolution they can introduce different types and amount of artifacts that are the acquisition ones. Coding artifacts that introduces blocking artifacts, so there's a lot of work on state of the art that has been exploiting this information. So this is a study that a master student did, JPEG, Plano, standardization group, and so we asked them, how can we simulate those type of located on the grid? So the difference between this column and this column is, you can see it here, this is randomly dropping points, and this is removing them along specific edges on the grid. And then we created our data set, and we did a first subjective experiment with 22 observers, and it was painful because during the pandemic you had to wear a lot of stuff under your head-mounted display, so this thing covering the hair, thing covering your face, so it was kind of tiring for all this discomfort. There was definitely discomfort there. We used an HTC Vive. You can see this. Look at the point cloud and to rate the quality of the distorted, so the one on the right side, on a scale from 1 to 5. Just to give you an idea, this is how I don't know if it's confusing, but okay, she's walking around and looking at the point clouds from different perspectives. Then we collected all the results, and we studied what happened for different types of distortions, and especially what happened, for example, for, okay, let me show you. We have the orange bars that are showing us what happens when the noise is applied only on the borders, on the edges of the point cloud, while the light blue ones show what happens when we apply the distortion randomly to the entire point cloud. So in both cases, you can see that, for me, surprisingly, people, okay, let me give you another information for reading the graph. This is distortion level, lowest distortion level, highest before, and this is the mean opinion score. So 1 means low level, 5 is the best level. So who rated 5? No one here, but said that the quality was very high. So surprisingly, and this is already a difference with respect to 2D, we have that noise applied on the edges was less annoying, or considered less annoying with respect to when the distortion appears on the other parts of the point cloud. So as I said previously, when we're discussing about 2D, the edges are quite important. If you touch the edges in a 2D environment, then the quality drops quickly. In this case, probably because we are dealing with point clouds that are completely different, if you remove points here and there on the edges, people seem to care less. And then what we see, another interesting thing, is the comparison between when the noise is applied only on randomly on the point clouds, or where it is applied, no, sorry, not the noise, when the points are dropped randomly or from a grid. And in this case, let's say the pattern, when the people could identify pattern in the removal of those points, were considered less quality with respect to a random dropping. So this is the first thing we started investigating, and actually it's something we will do also with Jesus, hopefully with some of you. And there's another component, that is studying how people move around the object. So we recorded also the position, and this is something we are investigating a bit deeper now, but I don't have that much in space. And people didn't also get, in height, because some people just bended to look at the point clouds. Not so many, because again, if this is tiring, this is definitely more tiring. Another thing that we thought, we understood, is that when you have more distortions, people will start moving more. Maybe because they want to see better all the point clouds from different perspectives. But then these things change. So the results, we got them a couple of days ago, maybe. So we have some students who are studying those data, and the horrible news is that the exploration pattern depends only on the viewer. So everybody has his own exploration pattern. On one hand, this is kind of telling us that there's plenty of work to be done. So, wrapping up. Quality of experience. I hope you got more or less what is the quality of experience, even if I understood most of you know what it is, that there are many influencing factors that we still have to understand how to model. But we have some facts. So we are used to 2D, where we could define models that were working more or less for everything. Now this general purpose assessment is no more possible, and it depends on all the things that I mentioned, especially on the application, on the user, on the devices that we're using. And interaction is more or less never covered, because it's difficult multimodal interaction. So we are adding the possibility of touching. But the funny part is that this is an hologram. So for the Jubilee that they had in June, since she was not able to go around eventually, they created an hologram. So we have this queen, a much younger queen, waving hands in her, I don't know what's the name of it, carriage. Already, we are moving towards using this kind of, towards using this kind of application for many, many different purposes. So, yes, I've been quick, so we have time for questions if you have. Yes, so you have my contacts, I think, in the first slide, especially for Juan. I put it back, and if you have any curiosity or things you want to ask. we can use this 10 minutes left.